In 2013, Voyager 1 achieved a historic milestone by becoming the first human spacecraft to enter interstellar space, completing the feat 36 years after leaving Earth. The current observatory is 14.5 billion miles from Earth, causing messages to take approximately 20 hours and 33 minutes to be sent and received. NASA experts did not expect Voyager 1 to continue space exploration for more than 6 months, but the vehicle exceeded expectations, having discovered 500 unknown objects in space. Now, world-famous podcaster Joe Rogan has joined the discussion to share the incredible results of this extraordinary discovery. What are these mysterious objects? Are they related to aliens or a malfunctioning plane? Join us as we explore how Voyager 1 detected 500 unknown objects floating in space and discover Joe Rogan's incredible findings. Have you ever wondered why, despite the unimaginable vastness of the universe, we do not pursue real evidence of alien civilization? This problem is called the Fermi paradox, and it has been a mystery that has fascinated scientists for centuries. However, a recent encounter in the depths of space has surprised scientists and may shed light on the age-old question of whether aliens exist. Joe Rogan, an expert and podcaster known for discussing aliens and the possibility of extraterrestrial civilizations, has previously hosted guests like David Grush and other researchers on the possibility of life beyond Earth. Now, new data from Voyager may first be the key to answering the question of whether we are truly alone in the universe. Buckle up as Joe Rogan explains why Voyager 1's announcement that it has detected 500 objects traveling through space is a game-changer, and how it can impact you no matter where you are in the world. But before we get to the fun part, let's understand how Voyager 1's mission happened. Isn't it surprising to think that our wonderful world, with its endless oceans and towering mountains, is just a small part of the bigger universe? Scientists have wondered about this for centuries, but it was not until the 1970s that NASA scientists had the opportunity to understand the scale of our community. It all started with the unexpected conjunction of the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. Amidst the celestial dance, a medical student named Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while studying at Caltech, came across a highly surprising discovery. By carefully calculating and plotting the orbital paths of the giant planets, Flandreau discovered a phenomenon in the sky that would revolutionize space exploration. Flandreau's findings were nothing short of encouraging. In the late 1970s and early 1980s, these 4 planets were tracked in a fascinating arrangement, like pearls in a cosmic necklace, with Earth among them. This discovery created excitement at NASA because it offered an unprecedented opportunity to improve space travel. By using the gravitational assists available from each planet, a spacecraft could propel itself forward using a force similar to the pull of invisible cosmic strings. Flandreau's prediction suggested that gravitational assists from the giant planets could reduce the flight time between Earth and Neptune from a daunting 30 years to just 12 years. However, there was a catch. This magnificent alignment occurs only once every 176 years. Recognizing the importance of this once-in-a-lifetime opportunity, NASA embarked on a mission to explore the planets. 2 spacecraft, Voyager 1 and Voyager 2, were built with the same design and mission, launched 15 days apart in the summer of 1977. The twin explorers aimed to uncover the mysteries of the solar system and beyond. Voyager 1 was launched on September 5, 1977, and became a key part of the Voyager program, a testament to humanity's curiosity and quest for knowledge. For nearly 50 years, this incredible spacecraft has continued to travel, bringing valuable data back to Earth via NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, bridging the gap between our known world and the unknown beyond. While marveling at Voyager 1's incredible journey, it's worth noting that it's only a breath away from Earth. As of August 2023, the observatory is an astonishing 14.5 billion miles from our planet. Carefully designed and built by the brilliant minds at NASA's Jet Propulsion Laboratory and powered by the Titan III launch vehicle, it began its adventure from Launch Complex 41 at Cape Canaveral Air Force Station. Just when you think you've seen it all, the truth emerges. Now, let's take a deeper dive into this amazing expedition of 500 unknown objects floating around in space, and the fascinating explanation Joe Rogan recently gave on the Joe Rogan podcast. How did Voyager arrive in interstellar space? Imagine a space explorer venturing into the great unknown and conquering the vastness of deep space within a decade. That's Voyager 1 for you. This brave spacecraft is already an incredible 14.5 billion miles from our planet. Take a moment to think about this. This distance is equivalent to traveling approximately 3.6 times the length from Earth to the Sun in 1 year. But there's much more to Voyager 1 than speed, distance, and longevity. It also delivered a big reveal, including the recent discovery of 500 unknown objects hidden in the vast expanse of space. This finding is unlike anything we have seen or analyzed before. It is a treasure trove of cosmic mystery and wonder, and we are about to unveil the details of this revelation. You may wonder how a spacecraft launched in 1977 is still operating and providing such exciting information. The answer lies in the excellent engineering and vision that went into Voyager 1's design. One of the main secrets to its longevity is the presence of 2 backup computers. Voyager and its twin, Voyager 2, are equipped with 2 computer subsystems, the Flight Data Subsystem and the Attitude and Articulation Control Subsystem. This redundancy is an ingenious move that ensures the flexibility of systems and the ability to activate computer components when needed, prolonging their lifespan. The computer system on the Voyager spacecraft is configured as a distributed system consisting of 3 dual redundant computers. This intelligent planning ensures that even if one of the systems fails, the others can manage the mission smoothly, preventing the main goals from being compromised. To make the most of limited power consumption, Voyager devices rely on wired logic. In other words, computer systems are designed with complex algorithms that operate within energy budgets and time constraints. Power management during spacecraft construction was a crucial factor in maintaining operational integrity. Voyager 1's distance from the Sun poses a significant challenge to its ability to harness solar energy effectively. To maximize energy efficiency, engineers had to find innovative ways to optimize energy use. One such strategy involves prioritizing power for critical processes. Engineers carefully examined components or subsystems that were non-essential to the mission. For example, the heaters of some scientific instruments were disabled. These heaters were designed to ensure that the equipment was kept at a certain temperature for efficient operation. When turned off, they reduced energy consumption, extending the overall service life of the spacecraft. However, don't think decisions about power management for critical processes are taken lightly. It involves a comprehensive analysis of trade-offs between energy savings and mission objectives. Engineers work closely with scientists to ensure that removing certain procedures does not compromise the quality and usability of scientific data. The goal is to strike a delicate balance that maximizes energy efficiency while maintaining critical performance. Voyager 1's power management system can adapt to changing environments. As the spacecraft moves away from the Sun, solar energy decreases, but Voyager 1 adjusts its power consumption accordingly, ensuring sufficient resources to support critical operations and data transmission. It's like having a smart energy saver on board. Over the years, significant technological advances and improvements have been made in power management. Engineers continue to refine Voyager's power utilization through enhancements such as increased power delivery, improved battery charging systems, and sophisticated electrical and thermal management. Thanks to these effective energy management strategies, Voyager 1 has exceeded all expectations. Almost 6 months after its launch, it continues to provide critical insight. Considering that this spacewalk was first conducted only 5 years ago, the longevity of it is truly surprising. It speaks volumes for the dedication and creativity of the scientists and engineers who worked tirelessly to operate Voyager 1. But let's not forget, the depths of space are full of surprises, so hang in there because more discoveries are coming. Designed to explore the vastness of the solar system and beyond, the Voyager mission is equipped with an impressive array of electronic instruments and systems. These instruments were nestled into the spacecraft's fuselage, consisting of 65,000 individual parts. Although Voyager began its interstellar journey with a variety of functional devices, only 4 remain operational on Voyager 1 and 5 on Voyager 2. One of the long-term instruments aboard Voyager 1 and Voyager 2 is the low-energy charged particle instrument. This device features 3 sets of particle sensors that measure the number and speed of low-energy particles hitting it, tirelessly observing cosmic radiation and detailing the Sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively searches for high-energy particles from the Sun and other galactic sources. Cosmic radiation instruments now detect materials emitted from the vast interstellar space and the protective bubble formed by the Sun's influence. These readings prove crucial in determining when Voyager 1 entered interstellar space. It is worth noting that the device is still operational on both Voyager 1 and Voyager 2. Featuring 2 long antennas at right angles to each other, the plasma wave subsystem is a vital tool for measuring the electromagnetic field of potentially undiscovered exoplanets. However, its role evolved as Voyager entered interstellar space. Today, the device provides information on how plasma waves change as they travel through space. Moreover, magnetometer behavior studies make influences on each other mutually. Originally designed to study the magnetic fields of outer planets, the magnetometer now plays an important role in investigating the transition zone between the Earth's outer core and the central core. Scientists use the data provided by the magnetometer to study the forces that hold the solar system and the forces at work in interstellar space. Completing the array of functional instruments, the Plasma Science Instrument, PLS, is exclusive to Voyager 2. It continuously measures solar wind density, speed, and temperature, making it an invaluable tool for understanding space physics. The solar wind is a stream of charged particles from the Sun's corona that affects the planets. Analyzing the solar wind in the solar system and interstellar space reveals changes in the Sun's magnetic activity and contributes to our understanding of cosmic phenomena. On the other hand, the farthest radio signals from Earth are carefully received and analyzed to provide clues about the outer reaches of the solar system. As you can see, each instrument aboard Voyager 1 and Voyager 2 has evolved to play an important role in unraveling the mysteries of the cosmos. But that's not all. There is something even more amazing. Join us as we reveal the fascinating results of Voyager 1's latest adventure, which was recently discussed on the Joe Rogan podcast. When Voyager 1 entered interstellar space in 2012, it made groundbreaking discoveries about the space environment beyond our solar system. Voyager 1's magnetic field, plasma waves, and cosmic ray sensors revealed significant differences in particle density and plasma waves in interstellar space compared to the Sun's protective bubble. These observations provided crucial evidence of the interstellar medium. The data Voyager 1 collects continues to reveal important insights into the region beyond the heliosphere, allowing scientists to better understand the transition from the solar system to interstellar space. These latest Voyager 1 findings, discussed on the Joe Rogan podcast, have reignited public interest in space exploration and open new perspectives on humanity's place in the universe.